All right, we're in Algebra 2. Today's date is Monday, February 3rd, 2020. We're talking about the unit circle. So our objective today is to, oh man, I forgot to do cards again. I'll just try to do a mental memorization. What is our objective for today, Beverly?
Use trigonometry to find x and y coordinates on a unit circle in both degrees and radius.
Beautiful, there it is. All right, so again, what is a unit circle? It's centered where with a radius of what? India. It does have a radius of 1. Everyone write it down. R is equal to 1. Anyone know where the unit circle is centered? You can either give me the coordinates or you can tell me the name of those coordinates. There's only one thing of coordinates, one set of coordinates that has a name. Loria? You're correct that coordinates are generally labeled x, y, but I was looking for like the numbers. What is x and what is y? But thank you. Your card is now taken. Ellery? 0, 0. Yeah, the most basic you can get. So centered at the origin, or 0, 0. Cool, thank you both. All right, so this is generally what we have. We have a unit circle where I'm going to drag this point around, and I don't know what the x and y coordinates are, so we need to come up with our own formula that will always give us a value of x and always give us a value of y. And notice that my line that makes a right triangle always goes to the x-axis. That's going to be universal so that we don't have to learn two different rules. If I give you one that has a dashed line to the y-axis, then I have to teach you two different rules, and I only want to teach you one. I only want you to have to memorize one. All right, so what's going on here? First of all, we need to make sure that we have a right triangle. Again, our goal is to figure out an equation that says, hey, if I want to find the x-coordinate, just do blah, blah, blah. If I want to find the y-coordinate, do blah, blah, blah. So first, make a line that goes to the x-axis. And it doesn't matter where this point is. If this point was down here, let's go this direction, was down here below the x-axis, it's still going to go up. This should make a right angle. If I don't have a right angle, then I can't use trigonometry. Really, do you need a pencil? Oh, you have one? Okay. So from here, what do we know about this? If it's a unit circle, something is labeled 1. Ellery again? Radius is 1. Everyone labeled it as well. We know that that is 1. We also know some other things about the sides of this triangle. Obviously, we have the angle. Here's theta, some unknown angle, because I can drag this point anywhere around this circle. So this theta is definitely going to change. But this value, in terms of x, y, this length right here, I actually know in terms of x and y. Does anyone have an idea? How long is this? What is the height? Yeah, India? The height is always y. We can actually label this length y, because if I go x to the right and y up, that means that I've gone y up. This distance must be y. Everyone label it in your notes. This length is y. This length is x. With a quiet raised hand, someone explain to me why this bottom length is x. Someone regurgitate back to me. Why is this length x? Anna. Yeah, so that's another way to explain it. So we have an x-axis and a y-axis. Yeah, and then someone else, why is this not 2x or 0.5x or some version of x? Why is it exactly x? Depending on the point that we have. So we're either scared or we don't know. It's probably a mixture of the two. If we define this point to be x and y, maybe you want to think of it as a certain point, maybe like 1, 2. This distance must be 1 because in order to get beneath this point, I must have traveled this amount to the right. So this amount and this amount should always match up. This and this always match. All right, so from there, I'm just going to use a trig function. What is a function that relates x and 1? You have 3 choices. You have a 33% chance of getting this right. Is it sine, cosine, or tangent? If this is my angle of reference, and I have these two measurements, what trig function am I using? Sorry, Ellery, I have to give it to someone else. Sorry, India. I'm going to take someone's imaginary card right now. Yeah, Sam. It is indeed cosine. Cosine of that angle. Cosine of theta. And can someone else tell me what the ratio is? Cosine of theta is equal to, is it 1 over x, x over 1? Which one is it? Quiet, raise hand for this one. What is cosine of theta? What ratio is it? And if you know it, go ahead and write it down. And you can also set it up for using y in 1 as well. Emily? It is indeed x over 1. And when I think about these, I'm always spelling out, or sounding out so-ka-to in my head. So, ka, C-A-H. C, and adjacent is x, the hypotenuse is 1, so cosine is equal to x over 1. Can someone do the trig ratio for using y in 1? If I'm using these two side lengths and I have my angle of reference down here, which trig function am I going to be using and what do I actually write here? Sorry, Ellery. Let's get more people in here. Yeah, Cheyenne. Yes, sine. And do you know the ratio as well, Cheyenne? So, it is indeed y over 1. Is everyone okay deriving these formulas? We're just using a trig function. And the fact that we're on a unit circle make this a really nice problem. Because it's a unit circle, this denominator will always be 1, which means we have our formula. It's already done. We don't even have to do any more math. Come down here. X. To find your x, you're always, 100% of the time going to be just doing cosine of your theta. To find y, it's always going to be your sine of your theta. All I'm doing is getting rid of the 1 that was in the denominator. It used to be y over 1 is equal to sine of theta. That's the same thing as y is equal to sine of theta. And this is something that's going to reoccur over and over again throughout mathematics and physics. So eventually you guys are going to be with Mr. Brown and taking maybe physics, maybe environmental science, right? But in physics, you're always talking about, well, you have to do, whenever you have projectile motion, if I fire a rocket or a cannonball, you have to separate the motion into the x and y components. Well, how do you break apart those components? Using the cosine or using the sine. That's how you break them apart. So these are going to be coming up later again. All right, so let me talk about using the degrees and radians. So so we always start here at the right. This is our start. Everyone write it down. Our start is on the right. Same thing for radians. Our start is on the right. And that seems a little bit unintuitive, and it was to me when I first started as well, but I realized that whenever you're dealing with things that are starting on the ground, it makes sense for things to start on the ground instead of in the air. But whenever you go into the Air Force and you want to study mathematics with them, they actually will change that so that your starting point is up here. So it does change depending on what field you are in. But for all of high school mathematics, our start point is going to be at 1, 0. So if I start at 1, 0 and I travel, let's do it with degrees first. I go from here to here, and I'm leave some room on the outer space because eventually I'm going to go from here to here, from here to here. So just do the inner one first. In order to travel between from just this line here to this line here, how many degrees have I moved? This is kind of the easy give me. How many degrees have I moved, Luria? Exactly. This is 90 degrees. Everyone label it 90 degrees. It seems easy now, but once we start dealing with radians, these do get more and more confusing. What about this next one? Nice and easy again. I can draw that slower and maybe make this neater. If I'm starting here and I go a half a turn, how many degrees have I moved? Caroline? 180 degrees. If I start here and move all the way around here to this one, how many degrees have I moved? And do you still have your imaginary card, Beverly? No. I'll give you guys a hint. You're really moving in chunks of 90. I'm going to call on Chewy in a sec. But your hint for everyone is 90. 90 times 2, 90 times 3, 90 times 4, 90 times 5. You keep multiplying by integer numbers of 90. And Chu, you get, it is indeed 270 degrees. So what I'm trying to show by this is eventually I'm going to be giving you a point that's like right here. The way to find this point is I first go 180 and then I go backwards 30 degrees. Or maybe I go 270 and then another 15 degrees, or backwards 25 degrees. So always start at these axes and then move from there. You'll see that if you flip over to the back side, that's exactly what I'm going to be giving you. Oh, from this one, we start at 90 degrees and I give you an additional 30 degrees. Or over here, I start at 360 degrees and then I go backwards 45 degrees. And of course, a full turn is 360 degrees. I'm not going to put that here. And now the radians is a little bit more difficult. How do I get a quarter of a turn? How many radians have I rotated? You can't be throwing things, guys.
I didn't throw it.
He was kind of cold.
I should have neck thrown it.
It sounds very crumply to me.
There's trash in there because he keeps his pockets.
Okay, yeah, lovely. So how much is a quarter of a rotation in radians?
What was the question?
In radians, how much is a quarter of a turn? Does anyone know this? I'll give you a hint. A half a turn, the definition of half a turn is pi. So let me try making this. I can't draw semicircles very well. This is pi. Therefore, a quarter of a rotation is what? The same two hands. We almost have everyone in. Yes, Jaden. Half of pi. So the way that we write that is pi over 2. Everyone write down. A quarter of a rotation in radians is pi over 2. And therefore, 3/4 of a rotation is what? 3/4 of a rotation is close, not.
I give up. That's why I don't raise my hand.
Don't give up.
Nope, two.
Leo, go for it.
2.
2. Just the number 2 like that? Not quite. You should have a pi in there somehow. 2 pi would be, here's 1 pi was the yellow, and then 2 pi would come all the way back. So I can say, can everyone write down Leo's answer? So if I go all the way back to the beginning, that's 2 pi. Just like if I went all the way back to the beginning, that's 360 degrees. But a 3/4 of rotation is 3/4 of Leo's whole 2 pi. So I can actually do the scratch work off to the side. Well, 2 pi is a whole rotation, and if I multiply that by 3/4, then that's 3/4 of a whole rotation. I can cross cancel. 2 and 4 turns into 1 and 2, and this simplifies to what with a quiet raised hand? Who do I still need to get in here? Yes, Aurelio. Multiply all the top. What's 1 times pi times 3? 1 times pi times 3. 3 pi. And what's on the denominator? 3 pi over 2. Aurelio has it. This 3/4 of a rotation is 3 pi over 2. Thank you, Aurelio. I believe in you, even if you don't believe in yourself.
I give up a year ago.
Thank you, guys. We all believe in you, Aurelio. All right, so with that, you have a quick little cheat sheet of what happens if I start on this negative y-axis and then I move forward a little bit. We'll take 3 pi over 2 and add a little bit to it. So let's come down here and do some example problems. So the instructions say we need to find the value of the x-coordinate of point A. Well, I need to stop and think. X-coordinate, is that the cosine or is that sine? Do you guys remember off the top of your head? X is, you'll shout out, cosine. So already, I should be able to come down here and say, this is cosine of some angle. But what angle is it? It's not 30 degrees. And that's the biggest misconception I see when I'm looking at Khan Academy. People just enter 30. But you started from here. You don't start from here. So I have to add this angle plus the angle that was given to me, and I get what? I think, is everyone in yet? India? It is indeed 120. Let's try another one. Again, 120 because I added this 90 degrees. Well, now I am going to start from all the way around to 360 degrees and then go backwards 45 degrees. So you'd be correct in saying, let me write this answer down. That Khan Academy doesn't like this. They like positive whole numbers that are less than 360 degrees. They say enter your answer between like 0 and 360 degrees. You could say this is sine of negative 45, but they don't want negative numbers, so I have to do a different value. And by the way, I kind of gave away an answer. If I'm doing the y-coordinate of point B, I'm talking about sine. So I could say sine of negative 45, but if I want to keep it with positive numbers, still less than 360, this is sine of what? So again, your hint, you're going to do a full rotation, 360 degrees, and then go 45 backwards from that full rotation. Who has it with a quiet raised hand? I can call on people multiple times now. India. 315 is indeed correct. And I should be putting degrees on here because if you don't have units, if you don't have this little degree symbol, you assume that you're in radians. To be formal about our mathematics. This is a good time to ask me questions because we're about to move on to something harder. Anna.
So this is all we do. We don't have to do like solve for it.
Nope, this is it today. Both in degrees and radians. So this example number 1 is one homework assignment. Example number 2 is the second homework assignment. Very similar, but in different units now. All right, I need to find the x-coordinate of point C. Well, first of all, x, is that cosine or sine? So quiet raise hand. Is x cosine or sine? Beverly. All right, so we're going to write it down. This is cosine of our angle. Okay, so now from here, it's giving this angle of reference between here and here. So I have to start here and then add on pi over 3. So to get from our start 3/4 of a turn, whatever we found for us last time, and then I have to add another pi over 3. I'm going to have to do some scratch work because now I'm adding fractions. So remember back from our notes, if I do 3/4 of a turn, that's 3 pi over 2. And these are things that you're eventually going to need to memorize. 3 pi over 2 is pointing straight down. If you memorize it now, you'll have far, far less to memorize in the future. So essentially, I started here at 3 pi over 2. I'm doing my scratch work on the side. And I'm going to add an additional pi over 3. If I add those together correctly and simplify my answer, that is what I'm looking for. So what is 3 pi over 2 plus pi over 3? And I'm not going to call it the first person, but I can call them people multiple times now. Giving you guys a hint in case you're spinning your wheels and you're stuck. I need to have common denominators. So to do that, I'm going to multiply the right fraction by 2 over 2, multiply the left fraction by 3 over 3. There's your hint. Someone needs to give me an answer now. I see one person has it. I'm giving you more time. I see people doing math. I need you to have time to do your math. I'm going to call on Ellery in 5 seconds. I want to give you more time to think about your math. All right, yes, Ellery.
Can you also just cancel out those 3s?
You can't cross-cancel the 3's unless this is a multiplication symbol.
Okay.
Yeah, good question.
Then you would have 9 pi over 6 plus 2 pi over 6.
For a total of
11 pi.
11 pi over 6. There it is. Thank you, Ellery. And let's try the last one all together. So it looks like for D, first, is it sine or cosine? I'm trying to find the y-coordinate. Beverly? It is indeed sine. Sine is paired with the y-coordinate. Sine of how many radians, though? So again, it looks like the angle that they're giving us is in between here and here. So I have to first go to this angle and then go backwards pi over 6. So I'm actually going to be subtracting an angle instead of adding an angle now. So how many radians does it take to get a half rotation? You have to look that back up. And then subtract pi over 6. You're going to have to play with some fractions a little bit. And then I'm expecting someone to walk me through this entire process. I'm going to have to use my summary area a little bit. Yeah, Beverly.
Pi minus pi over 6.
Pi minus pi over 6 is exactly the setup that we want because pi is a half of a rotation. And is it okay if I go on a slight tangent right now, or should we finish the problem and then do the tangent?
Finish.
Finish, okay, and then tangent. Exactly. So pi minus pi over 6, perfect. Did you want to give it to someone else, or do you want to keep solving?
I can try.
Yeah, go for it.
Would you have pi over 1, the first one, or no?
Yep, it's pi over 1.
Okay, and then you times the pi over 1 times 6 on both sides.
Perfect.
Then you have 6 pi over 6 minus pi over 6.
That's kind of the same thing as 1 pi over 6, right? Okay, and that's equal to,
5 pi over 6.
there it is. And there is the notes. They are now completed. Now it's time for me to do my tangent. But before the tangent, yeah, sorry. Are there any questions on how to do anything from the notes today? Can you guys give me a fist of 5? How well do you think that you can solve problems like example 1 and 2? These 4 problems here. Give me a fist of 5. How well do you think that you can do it? 5, 4, 3, 5, 2, 4, 3. Really, what do you got? Oscar, Jaden, what are you guys at? 4, 3, 4,
I used to
5,
remember those weird pi whatever. I'll give you 3 though.
3, 3,